As we go along with different stages of program development, we can make use of documentation to describe what the program is and how we can use it. A lot of people mix it up with user manuals, so here are differences between a user manual and a program manual. For a user manual, it aims to facilitate the common users, but with a program manual, it facilitates programmers. Their major content is also different. For a user manual, it's about installing and starting the software. It also describes the functions provided by the software and includes steps of troubleshooting. As for program manual, it includes technical details about sample test data, algorithm, sample as well as input, output. The writing style is also very different. For user manual, they include non-technical diagrams such as screenshots, whereas in program manuals, it includes pseudocodes and program flowcharts. So why do we need program documentation? It helps programmers maintain the program in the future. Not only does it help people to become familiar with the program and programmers to discover errors in the program, users can learn to use the program by reading the program manual. There are different ways to solve the same problem. As we talked about the different approaches we can use to develop a solution to solve the same problem previously in the video. We are going to start by talking about top-down approach in a more detailed way. If we make use of the top-down approach, we need to start from system level, with the problem being divided into smaller and manageable modules. If you need to solve a large problem, top-down approach should be used. As we are using the top-down approach, it can be paired with stepwise refinement. If you are being given a full problem, you can make use of stepwise refinement to divide it into several sub-problems that are easier to solve. And this is called first-level refinement. You can further divide the sub-problems into sub-sub-problems, which can be solved even more easily than the sub-problems. And this is called second-level refinement. As for bottom-up approach, we start from component level, particularly if most of all components are ready. We will integrate the basic modules to form a larger module, and it is suitable for smaller problems. To design algorithms, we first need to know what an algorithm is. An algorithm is a finite sequence of steps arranged in specific logical order to generate a solution to a problem. There are two common methods for designing and representing solution algorithms, which are pseudocodes and flowcharts. Pseudocode is used to describe an algorithm in a narrative form, while flowcharts are used to represent an algorithm in a graphical form. The above methods are program independent, which is a plus when we're trying to solve a problem. To represent various kinds of operations in a flowchart, a set of commonly used symbols are used. The symbol can help programmers understand a flowchart visually and help trace any logical errors residing in an algorithm design more easily. To better understand how flowcharts and pseudocodes can help solve a problem, let's look at an activity. In this activity, we have 6 lines, and you need to fill in the box for content in each line. As the program starts, the program first runs the first line of the program, which is input A. Then it moves on to the second line, which inputs B. After going through the second line, it moves on to the third line, which involves A pointing to C. It refers to A equals C. In the fourth line, B is pointing to D, which refers to B equals to D. And in the fifth line, it shows A plus D, pointing to S, which refers to A plus D equals to S. At last, the content for the sixth line is output S. To identify the inputs and outputs of a problem, programmers have to define the inputs, processing steps, outputs, and their requirements for the program. These things are usually shown in an IPO chart as mentioned in Chapter 1. Do you know how to define input, processing step and output? If you don't, here are the definitions. To understand how the inputs and outputs of a problem is defined in the IPO chart, we're going to look at Activity 2. In Activity 2, a program is designed to read two numbers and print their total. According to the description of the activity, the two numbers are the input. One of the numbers is labeled as number 1 and the other labeled as number 2. The total number 1 and 2 should be the output. In between the input and output, there are a couple of processes that the program needs to go through. First, the program needs to read number 1 and number 2. Then it needs to add the two together. After adding the two together, the program needs to present the sum of the two numbers. After going through all the steps, the total of the two numbers are added together and presented in the program. Designing an appropriate user interface is also very important when it comes to success of software, especially for e-commerce systems developed for use in highly competitive financial markets. An attractive user interface with a high degree of user friendliness is essential for most software nowadays. To design a user interface, we should consider the following areas, which includes appropriate colors, having fields being consistently aligned, and using color objects appropriately. Wordings used should also be concise and appropriate. Beside the design of its layout, there are a couple of areas that should also be considered. For example, consistency in the interface and having different versions for different types of users. For the consistency in a user's interface, we should use the same color scheme and similar workings for similar labels. The buttons should also be put into the same places. Its design should be able to speed up the learning curve of users so that they can adapt to the design more quickly. Lastly, it should also be able to lower the cost of training and technical support. As for having different versions for different types of users, it aims to enhance the efficiency. For example, an interface is designed for data entry by school clerks, while other interface is designed for data correction by students. Help menus can be added to the student's version to guide them through the form, while the clerk's version can be kept as simple as possible. There should also be some fixed paths of navigation from one form to another with an interface to prevent users from being lost when going from one form to another. Placement of different elements should be appropriate on a user's interface. For example, Westerners are used to reading from left to right and from top to bottom. Then the design for Westerners should allow them to read in such sequence. To improve your design, you should also make use of users' opinions to give you some hints on how you can improve your design. This is the end of the video. Thank you for watching. Please give us a like and subscribe to our channel. Click on the tab to watch the next part of the video series.